Hello, this is Crowe, and I will be starting my YouTube video. Okay, workbook. Geometry first. Skiblam. This is our geometry. 0.5 by 1. Yeah. And then surface is mesh in here. I believe that's the next step. Mesh should be, yep. Mesh. Put on the sizings from the side so it gets smaller there, as you can well see. Put the name selections over here, bam. Then I believe that's everything important here. Yeah, name selections, airflow is the main body, and then the size. Inlet, outlet, plate, and far field pressure. Far field pressure is this top portion, whereas plate is the bottom. Next section is here, which is the setup, I believe. Anyway, let me see. There's a lot of stuff here. So first, I set the air to the right stuff, and then I set the something else to match the velocity. The velocity was, I believe, the inlet boundary conditions. Yeah, velocity of 2 there. Then we went through here. Yeah, okay. And next, I believe we just initialized and ran the calculation, getting from here on scaled residuals. This looks a little bit inaccurate because I pushed it twice. So let me just rerun it real quick. Calculation complete. Okay. Don't know why it still looks like this, but it is supposed to start here and go down like that. Anyway, next part is the contours. This is the main velocity contour. As you can see, you get that decrease in velocity here right at the boundary layer. Then there is the that's all that's important here, I believe. I use the forces here, I believe, to find the shear stress. But anyway, most of the graphs I did were in this section. Sure. What's up here? Okay. Starting at the top, contour graph. Turn off. So first of all, 3D viewer. Turn off the vector. Okay, here's a pressure one. You can just go to velocity. Bam, velocity one. Can increase it to be super detailed. Wow, I can hardly tell the difference between those colors anyway. That's kind of crazy. Let me go back to pressure. Skip lamps, you can see the vector well. Here's the velocity vector. So even though it's on top of the pressure contour, it's just, the velocity, as you can see, smaller, lower velocity near the boundary layer. Pressure has this big spike right here, and it gets gradually lower as it gets to the pressure outlet. I made some lines throughout here. Don't know why you can't see them right now. Maybe if I go to the contour. I don't know why you can't see them right now. But anyway, there's a few lines, 50 centimeters, 75 centimeters, 25 centimeters, and the flatline plate for the shear stress. Then we went on to a failed chart, my 3 velocity profiles. I guess I can't zoom in. But yeah, these are the 3 ones. Obviously red's 25, green's 50, and blue is 75. And then I believe this is the wall shear stress. Yeah, here's the wall shear stress. Skablam across the plate. And that should be all for the graphs, I believe. Yeah, okay. Then I'll also be doing the exporting because I'm just going to do exporting in my video because it is easier. That way the other person doesn't have to like get my files, my ANSYS files or something to show it, because that'd be kind of weird. But anyway, file, Not export. No. We go down to, oh, right here. Export. Skiblam. So this would be exporting the shear stress values. I would push save. It would save it there. And then I found it easiest to put it in Excel and then into the Google Sheets that we ended up doing. So it'd be text from CSV. We take this, import, skiblam, push load, and put it right there. And then I just copied it and pasted it into our Google Sheets right here. That way we have 25 centimeter, 50 centimeter, 75 centimeter, and wall shear. With the wall shear, okay, well, with the velocity, you're finding the boundary layer thickness, which you'll be doing. And then with the wall shear stress, we find the skin friction with this equation. And then coefficient of drag. Oh, yeah, I gotta do that. Coefficient of drag. Well, this is just a screenshot over here of what I did, just printing the values. Oh, that's actually incorrect. Let me fix that. That was when I used to have it set at 1 meter per second. Let me try to remember how to do that. Maybe shouldn't have done this in the YouTube video, but printing the oh, it wasn't in the screen, it was in this screen. This is what I use this for. Okay. Edit, plate, print. Awesome. Yep, that looks better. So I'm gonna copy that. Skablam. Skadoosh. Yep, that looks about right. And then skablam. Just in case he for some reason needs something else from here, I'm just gonna paste this whole thing in here for him to use. Skablam. Okay, and that should be everything. Awesome, right? Simulate the flow of a flat plate and answers flow from scratch. Yeah, and I put all of them in this Word file. Skadoosh.